Hi friends, welcome back to my channel. This is Varun. Today I am going to explain you about microprocessor versus microcontroller. We will talk about the difference between the microprocessor and the microcontroller. Introduction. A microprocessor is a central processing unit CPU that executes instructions in a computer. A microcontroller in a compact integrated circuit designed for specific tasks in embedded systems. While both are processing units, they differ in terms of functionality and applications. Now, microcontroller and microprocessor are differ in functionality and applications. Let's talk about it. Architecture. Architecture is nothing but the design of a microprocessor and a microcontroller. Microprocessors have a more complex architecture with separate components for memory, output, input, and processing. Microcontrollers have a simpler architecture with integrated memory, input ports, timers, and other peripherals on a single chip. Here, microprocessors have a separate components are more complex in architecture, whereas microcontrollers have a simpler architecture. This integrated design makes microcontrollers ideal for embedded systems where space and power consumptions are critical. Processing power. Microprocessors are designed for high speed processing and multitasking in applications like PCs and servers. Microcontrollers are optimized for low power and real time processing in applications like automotive systems and IoT devices. The processing power of a microprocessor is generally higher than that of a microcontroller. Title. Microprocessors are typically more expensive due to their complex architecture and higher processing power. Microcontrollers are cost effective because of their integrated design and suitability for specific tasks. Microprocessors are very expensive, so they are higher processing power. Microcontrollers are cost effective because of their integrated design. The cost consideration is crucial when choosing between a microprocessor and a microcontroller for a project. Programming. Microprocessors require external components like memory and input interfaces, making programming more complex. Microcontrollers have everything integrated on a single chip, simplifying the programming process. The programming languages and tools used to for microprocessors and microcontrollers may vary based on the application requirements. Here is a diagram which can represent the programming of microprocessor and microcontrollers, how they work on. Flexibility. We will talk about the flexibility of microprocessor and microcontrollers. Microprocessors offer more flexibility in terms of hardware customization and expansion capabilities. Microcontrollers are more rigid but are well suited for dedicated tasks without the need for extensive customization. The choice between a microprocessor and a microcontroller depends on the level of flexibility required for a particular application. Power consumption. Microprocessors consume more power due to high speed processing capabilities. You know, microprocessor is used in TVs, in laptops, or bigger electronic devices which uses high speed processing capabilities and uses more consumption of power. Microcontrollers are designed for low power applications, making them energy efficient for battery powered devices. As microcontrollers are used in smaller devices like toys, washing machines, and etc., they are used for less energy efficient. More power consumption is crucial factor to consider, especially in portable and IoT devices. Applications. Microprocessors are commonly used in personal computers, servers, smartphones, and high-end electronic devices. Microcontrollers find applications in embedded systems, automotive electronics, industrial control systems, and IoT devices. Understanding the specific requirements of an application is essential for choosing the right processing unit. Performance. We will not now talk about the performance of microprocessors and microcontrollers on their own ideology. Microprocessors excel in tasks requiring high computational power, complex algorithms, and multitasking capabilities. Microcontrollers are ideal for real time processing, low power applications, and tasks with specific timing requirements. The performance metrics of a microprocessor and a microcontroller differ based on the application demands. Now we'll conclude the microprocessor and microcontroller. Choosing between a microprocessor and a microcontroller depends on the specific requirements of the application. Consider factors such as processing power, cost, programming complexity, flexibility, power consumption, and performance. Both microprocessors and microcontrollers play crucial role in various electronic devices and systems catering different needs. Here is a summary of microcontroller versus microprocessor. Here applications is used in microprocessor used in computation, multi-core computation and fast communications. Microcontroller is used in embedded devices. Processing power higher for microprocessor and lower for microcontroller. Memory external flexible, internal limited size for microcontroller. Power consumption higher for microprocessor and lower for microcontroller. Size larger for microprocessor, lower for microcontroller. Size larger, smaller. Price expensive for microprocessor, cheaper for microcontroller. Thank you.